All right, in your textbooks, page 495, a short homework assignment last night, just 9 multiplication problems. And numbers 1 through 6 were monomials being multiplied by, not necessarily binomials, but polynomials. So monomial times polynomial, how do we multiply those first 6 homework problems, Lana? Good, distribution. And then for numbers 7, 8, and 9, we were multiplying binomials. And a couple ways we could describe that, but how would we multiply those binomials in 7, 8, and 9, Joshua? Foil, or also called?
Distribution?
Well, double distribution. Double distribution, right? Because you're distributing 2 things. But again, in a way, since it's both binomials, it'd be FOIL. Now, remember I showed yesterday, if you had like a binomial times something bigger than just 2 terms. Binomial, trinomial, binomial, 5, heaven help us, 5-term polynomial, okay? Well, that would still be double distribution, but it wouldn't be called FOIL anymore. But with binomials, we could certainly FOIL. Let's see how we did, again, thinking sign, number, letter, every time we multiply. So, Lana, we're going to have to think through sign, number, letter once, sign, number, letter twice. Now, there's not a number to worry about on the last one, but what did you get for your answer on number 1?
56h negative 24.
Good, 56h negative 24. Number 2, Joshua, sign, number, letter, we get?
15x positive 15y.
Great job, 15x positive 15y. Number 3, Lana.
3n cubed positive 3n squared.
Good, 3n cubed positive 3n squared. Number 4, Joshua.
18x cubed positive 36x squared.
Excellent. 18x cubed plus 36x squared. Lana, number 5.
D to the 4th positive d to the 4th negative.
Like something doesn't seem right there. Yeah, look at it again.
I think it's supposed to be d cubed.
Right, because d times d squared would be d cubed. So d to the 4th.
Positive d cubed negative 8d cubed. I don't know. I completely messed up that.
Well, look at the problem and figure it out. You've got a d times a d cubed. Is that d to the 4th?
What? For which?
On number 5, Lana, at the very beginning. We're starting over on the problem because you got confused, so we start at the beginning. Is d times d cubed d to the 4th?
Yes.
Yes. Okay. Is d times d squared d to the 4th? You said no, that should have been d cubed. Is d times negative 8d negative 8d cubed?
No.
No, should be
D squared.
negative 8d squared. There we go. So you look at it like, that's not right. That's fine. Start over. Rework the problem through. Number 6, Joshua. Oh, this is fine.
A squared bc positive ab squared c positive abc squared.
You didn't let it throw you off. Great job. That would have been so easy to get mixed up, but you took it. This multiplication is a squared bc. This multiplication is ab squared c. This multiplication is abc squared. And that's your answer. Nothing combines. Great job. On number 6, did you also get it, Lana? Great job there. Let me give you one more real quick, since there was a little bit of hesitancy there. Suppose we had a negative 5x cubed yz squared. Wanted to multiply it by a 2x, positive 5y cubed, negative 7xz to the 5th. At your seats.
Positive 5y cubed. I better say negative.
Whatever, multiply that.
Yeah, anyways.
Do what I wrote. Distribute at your seat, on paper. Sign, number, letter. we are taking way longer on this than we should. Stop where you're at. Josh, we are going to multiply this term times this term. That's my first step. And we're thinking 3 words.
Sign, number, letter.
Let's think them one at a time. Do not go ahead of me. Sign.
Negative
Number.
10.
Letters.
X to the 4th, y is z squared.
Perfect. Lana, we are no longer looking at this term. We're done with this term. We're now looking at this term. 3 words we should be thinking. Sign, number, letter. Do not go ahead of me. Sign.
Positive
Number.
25.
Letter.
X cubed y equals a squared.
All right, Joshua. We come to our last thing over here. We're done with that. Sign, Joshua.
Positive.
Number, Lana.
35.
Letters, Joshua.
X to the 4th, z. Oh wait, no it's not z. Y, z to the 7th.
There we go. The Y has no friends, but he still gets carried over there. That's what we should have done. It's not a whole lot of thought. It's just do. Sign, number, letter. Sign, number, letter. Sign, number, letter. We're done. Should have been very quick. And frankly, easy, unless you overcomplicate it. Do we understand what we're doing on distribution? Let's take a look at the next problems then. We had some binomials we were multiplying. Z positive 7, Z positive 2, either double distribute or FOIL. You're literally going to do the same thing either way. It's just 2 different perspectives on the same process. What did you get for number 7, Josh?
Z squared, positive 9z, positive 9.
Ooh, Lana.
It's not
Positive 14.
Positive 14 at the end. You're multiplying 7 times 2 to get 14. So remember, multiply, multiply, multiply. Sign, number, letter. Number 8, Lana.
3n positive 3n positive 1.
What?
Does that look wrong to you?
No.
It doesn't? 3n positive 1 doesn't look wrong?
6n.
Something looks funny there. Joshua?
2n squared, positive 3n, positive 1.
There we go. You did this, what Joshua did with 7 plus 2 at the end to get 9, and you're like, no, you multiply to get 14. You said n plus 2n is 3n instead of n times 2n is 2n squared at the very beginning when you multiplied the first together. n times 2n, 2n squared, not 3n. Don't add them, multiply them together.
Wait, so what was in the
2n squared, positive 3n, positive 1. It was just the first term that was messed up. And Josh, number 9.
36y negative 16.
Really close, Lana.
36y squared plus. Wait. There's no. 36y squared negative 16.
There we go, 36y squared, negative 16. Some little things. Let's do a couple more of those. Let's suppose we had a 5m negative 3n times, let's say, a 2m positive 7n. Go ahead and either double distribute or FOIL at your seats. Joshua, did you FOIL or double distribute?
I double distribute.
All right, let's start with the 5m, Joshua. What do we get when we distribute?
10.
Careful. Sign, number, letter.
Oh, 10 squared.
Good. And here, what did you get?
Positive 35n. Squared.
Wait, what?
Oh, mn.
mn. You multiply sign, number, letter. Do not make this hard. when we distribute the negative 3n, Lana? What do we get?
Negative 6 and then.
And here?
Me?
Yes, you.
Oh, I thought it was him.
No, I had him do the 5m to both. Now I'm having you do the negative 3n to both.
Negative 3n squared.
There we go. Now, if there's anything that can combine, let's do it. Is there anything that can combine?
Yeah.
Yeah, the outer and the inner, the middle two terms combined together. What should our final answer be?
10n squared positive 29 and negative 29n squared.
There we go. That should have been our answer. Try this next one. X negative 3 times 4x negative 2. Sign, number, letter. Sign, number, letter. Switch. Sign, number, letter. Sign, number, letter. Then see if there's any combining. But it's all multiplication on the first 4 steps. Or first multiply, outer multiply, inner multiply, last multiply. Then combine outer, inner. Lana, do you double distribute or foil? Foil. All right, first, outer, inner, last. All right, what did you get when you multiplied your first, Lana?
4x squared.
4x squared. Joshua, what would we get if we multiplied the outers? Sign, number, letter.
Negative 2x.
Good. Lana, when we multiply the inners, sign, number, letter, what do we get?
Negative 12x.
And what do we get when we multiply the last, Joshua, sign, number, letter?
Positive 6.
All right, we can combine the outer, inner. Lana, to get a final answer?
4x squared negative 14x positive 6.
There we go. Do you feel like we got a better handle on this now?
Okay.
And it's multiply, 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 multiply. Sign, number, letter, sign, number, letter, sign, number, letter, sign, number, letter. Combine like terms. Got it? Excellent. All right. Clear desk, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil. Everything else away. Sheet of paper, pencil, everything else away. And we'll take quiz 36. Quiz 36. When you get your quiz, put your first and last name in the name spot and today's date in the date spot. Today is 4/2/21. 4/2/21. 4/2/21, today's date. Pretty straightforward quiz. You've got several problems in which you need to distribute, and you've got a few problems in which you need to double distribute or FOIL. It's your choice. Think sign, number, letter. Work carefully, but quickly. Go ahead and get started. finishing up in the next few minutes. Myself, like cringing like this. So wasteful. Just crumpling up trees and tossing them. Like, I'll plant more trees, Just another minute to be finishing up. Alright, if you need just a tiny bit longer, you can pause the video. Our students in here are ready to move on. If you would, we're going to take just a quick break from algebra. We're going to get to our next algebra concept, but I feel like our brains could use a little bit of a rest from algebra. So turn to page 493. We're going to go back in time to our very first chapter of the textbook. And we're going to do some chapter 1 stuff on page 493. I want you numbers 26 to 34, the even. 26 to 34, the even, they're on page 493, and just rest from algebra for just a moment while reviewing some things we'll need for the final exam at the end of the year, and then we'll get back to some algebra concepts. But 26 to 34, working with some percents, working with some greatest common factor, least common multiple, just a change of pace, which I think our brains could use right now. Page 493, 26 to 34, there in the review section. Tell you what, work on the, do we remember greatest common factor, least common multiple?
That's what I was talking
That's what you were talking about then too long? All right, so remember greatest common factor, if we had, for instance, let me make sure I'm not using numbers they give you. Perfect, okay, so let's say we had 12 and 18. For the greatest common factor, you start by factoring this. 2 times 2 times 3, 2 times 3 times 3. And you're looking for what is actually common. They both have a 2. They both have a 3. So the greatest common factor is 2 times 3, or 6. For the least common multiple, it's a contest. Here's the winner of the 3s, that's a loser. Here's a winner of the 2s, that's a loser. So the least common multiple is 2 times 2 times 3 times 3, which is 36. Do you remember that now? Just do a quick refresher. Okay. I'll leave that up there. That's for the latter two. And if you need some help on the percent stuff, I'll get that poster out for you. Why don't you work on the GCF LCM while you wait for the poster on the other? But yes, glad we took some time to review this then, if we've been forgetting these things.
Are we still doing the percent one?
Yeah, but if, okay, I just found it. I must say, I mean, I've got that on the board already. If you needed the help with this, let me find those. Percentage base. It's been a little while since we've done that as well. Let me throw this up here for you. So maybe that'll be a help to you as you prepare those problems as well. And that's crooked. Help you out a little bit there, Scott. Zoom in where you can hopefully read that on your screen. You need glasses. In other words, next year when you're in my math class, you better wear your glasses to math class. Mm-hmm.
Especially while they have to.
It's still crooked.
Yeah, it is.
It's amazing when you stand on the side of something, though, it's so hard to tell whether something's crooked or not. You have to square up to something to see it. Also, too, the further away you get from something, the easier it is to see, right? You stand back away from it, you can really kind of get a full picture. That's true in your life with your parents. Your parents are far enough away from their teen years, they can look back and actually see with some wisdom. And when you're in your teen years, it's nearly impossible to have any wisdom about your own life because you can't see. You're right in the middle of it. Just a thought to chew on. Take just one more minute to see how far you can get. Even if you don't finish the whole exercise, still be a good review for us.
What do you multiply with?
Least common multiple. You find the winners. Who has the most 2s, the most 3s, the most 5s, the most 7s. If there's a tie, remember you just pick one to be the winner and you call the other one the loser.
I mean, for this coming back.
You find what's actually common. They both actually have 1, 2. They both actually have 1, 3. And that's all that's actually common. So that's what gets kept, the greatest common factor.
Oh.
All right, pencils down even if you're not finished. Put the pencils down. Let's check the answers you did get done. Number 26, what did you get for 27% of 30? Lana?
8.1.
Good, 8.1. We remember that 27% needs to be written as a decimal. Of means you multiply, and 30. And when you multiply, you get 8.10 or 8.1. Number 28 says 39 is what percent of 156? And Joshua, you got?
25%.
Good, 25%. Remember, to say is what percent of, you could say is what part of or what fraction of. That shows you clearly we're going to divide the 39 by the 156, add in some zeros there, end up getting 0.25 or 25%. And then 36 is 120% of what number, Lana?
300.
Ooh, careful, Josh.
30.
30, one too many decimal places. So here we would say that 36 is or equals 120% or 1.2 of or times what number x. And we divide the 1.2, remember we have to move the decimal over one place, and it's 360 divided by 12, which is 30. So 36 is 120% of 30. Questions on those three? All right, so just a little decimal error. All right, let's take a look at the greatest common factor, least common multiple of 24 and 32. What's the GCF, Joshua?
I was trying to find it.
Did not have the GCF. How about you, Lonnie? It is 8. Good. When you factor the 24, you should get 2 times 2 times 2 times 3. And then for the 32, should get 2 times 2 times 2 times 2 times 2. Right? So there's 24. There's 32. Well, they both have a 2 common. They both have a 2 common. They both have a 2 common. That's all they have in common is 2 times 2 times 2. So the GCF is 8. What about the least common multiple? Joshua, did you find that by any chance? Did you have that, Lana?
96.
96. Clearly the winner of the 2s is the 32. It has 5 of them. So, sorry 24. 3 2s is a lot, but you're still a loser. And I have such a nice way with words. And the 24 is the only one that has a 3. So by default, he's the winner. So you multiply the 2, 2, 2, 2, 2, which you already know is 32, times the 3, and you find the least common multiple to be 96. How about on the 20, the 25, and the 50? And you might be able to do this in your head just by looking at it, Joshua. What is the biggest number that is inside 20, 25, and 50? 5. And if you were to take the time to factor 2 times 2 times 5, 5 times 5, 2 times 5 times 5, well, they all at least have a single 5, but that's all they all have in common. So the greatest common factor is just 5. But for the least common multiple, remember, here's where we come down to the contest. The winner of the 5s is a couple of them, right? It's a tie, either these two or those two. Well, I like these two. Loser. All right, loser. All right, the winner of the 2s, right here, loser. So 2 times 2 times 5 times 5 gives us a least common multiple of 100 is our least common multiple. And again, that might be something you could have just figured out by looking at it. What's the smallest number that 20, 25, and 50 can become? Well, they can all become a 100, right? Multiply the 1 by 5, the other by 4, the other by 2. Yeah, they could all become 100. So that's your LCM. So there's the factoring way. And then sometimes with numbers, it's like, well, it's got to be this, right? And sometimes you can kind of figure it out that way. Questions on this? A good review for us. Flip back to page 491 now. And we're going to kind of put what we've been doing in reverse. We've been multiplying. Now we're going to do the opposite. And we're going to divide. But you know what the 3 steps are still going to be as we divide by a monomial? Sign, number, letter. You guessed it, Josh. Sign, number, letter continues to be our 3 key steps. Division's the opposite of multiplication, right? So if I were to multiply a 3x times a 2x plus 1, what would that give me first of all? Just real quick distribution. Lana?
6x squared and then positive 3x.
Good, positive 3x. Well, here's the deal. If I multiply a 3x times 2x plus 1 to get this, you understand I should be able to divide the 3x back out, correct? Just as if I say 4 times 5 equals 20, then if I take the 20 and divide out the 4, I should get the 5, right? So if I just multiply 3x times 2x plus 1, and I get 6x squared plus 3x, I should be able to take 6x squared plus 3x and divide the 3x out. What we're going to do is the opposite of distribution. We're going to divide sign, number, letter. Sign, positive, number, 2, letter, subtract the exponents, x.
Oh, yeah.
Sign, number, letter again. Sign, positive, number, 1, x's cancel.
Oh, yeah.
And there's my 2x plus 1 again. So we're going to do the opposite, sign, number, letter. Look at the example problem there on page 491. They give you a 16c cubed, I'm going to go ahead and put it on the board, negative 10c squared, negative 2c, and we're dividing all of it by a negative 2c. Well, just as with a distribution problem, we multiplied sign, number, letter, sign, number, letter, sign, number, letter over and over again, so here we're going to divide sign, number, letter once, sign, number, letter twice, sign, number, letter 3 times. Okay? But again, the key, just like it was with distribution, is ignore all the other noise, ignore everything around you, focus on what's important. Like in a baseball game, Glenn, when you come up to bat, you don't care about the noise, you don't care about the catcher, you don't even care about the base runners. That's the coach's job. You care about the ball coming out of the pitcher's, you don't even care about the pitcher, just the ball that's in his hand, right? Everything else has to be tuned out, you're probably going to strike out. We have to tune out all the other noise, we're locked in only right here, sign, class, because they're different, number. Because we are dividing, remember? And here, remember, we subtract the exponents.
C squared.
C squared. Ignore that. Now we're here. Sign. Number.
5.
Dividing. Letter.
C.
To the first.
To the first. Or just C. Because I'm lazy. Good. You're lazy too. I like that. All right, here at the end, everything else is noise. This is what we're focused on. Sign.
Positive.
Number.
1.
Letter.
C's cancel.
C's cancel, so there are no letters left. There's my answer. So, again, it's kind of like what we were just doing. It's just division now. Yes, sir?
How do you know what to divide by?
You're dividing by this. You divide by whatever's in the denominator.
Oh, they give you the...
That's what they did, right? Look at letter A on page 491. Are you on page 491?
Yeah.
Look at example A.
Oh, yeah, they do.
Yes, they give you the denominator. They give you the negative 2c. Yep. So turn the page now. Let's look at page 492. And let's take a look at just number 2. What are we dividing by, Joshua?
4.
On number 2?
Oh, on number 2.
Number 2. We're dividing by a 9. Okay. So how many times are we going to divide by 9, Lana?
9.
No. How many times? Twice. One time we're going to take the 54m and divide it by 9.
Yeah.
And then when we're done, we're going to take the positive 36p and divide it by 9. So we're doing 2 separate divisions. Now, I will say this. The book recommends that you write this as 3 separate division problems. 16c cubed divided by negative 2c. Negative 10c squared divided by negative 2c. Negative 2c divided by negative 2c.
No.
But I am lazy. So, if you can be smart, you can be lazy. If you can realize you're dividing by this, dividing by this, dividing by this, and you keep coming back over it, fine. But if you needed to write them separately, you could do that. At your seats, just do number 2, divide by the 9. Should take you about 10 seconds. Sign, number, letter. And what did you get? I think your pencil went down first, Lana.
6m positive 4p.
Did you get 6m positive 4p? Good. Number 4. What are we dividing by, Lana?
Negative 7.
How many times are we going to divide by negative 7, Joshua?
2.
Twice.
Yeah.
Do your sign, number, letter twice. Go. Number 4. Joshua with the win this time. Put that pencil down with authority.
because, like, you know.
What did you get, Joshua?
Negative 4x squared positive 2x.
Good. Negative 4x squared positive 2x. Did you get that?
Yes, I just thought at first 28 divided by 7 is 14.
Careful. All right. Do 6, 8, 10, 12. 6, 8, 10, 12. You're going to have to think letter on 6 and 8 and sign number letter on 10 and 12. But really, we always think sign number letter. Subtract the exponents. We are dividing like bases here.
Wait.
All right, this is weird. The first sign number letter is easy, right, Lana? Sign,
Oh, negative 4.
number,
Okay.
no, number. Focus, focus, focus. Sign is negative, number,
4.
letter.
Okay.
Look at the next one, Lana. Sign,
Negative
number,
1.
letter,
Okay.
but in the denominator.
I didn't
What?
even notice that.
Oh, right.
Right? Yeah, kind of weird. They
And then number 8, I'm a little confused on.
Number 8 should be a lot easier. No, I didn't really look at number 6 closely. I'm like, whoa, that wasn't supposed to be till Monday's lesson where they had fractions in the answer. That's stupid of them. Let's take a look at number 8. We had a 5np positive 6n divided by n. All right, so Lana, you said you were a little confused on 8. Sign,
5.
sign,
Positive.
positive number.
5.
The n's are going to,
Cancel.
so all I'm left with is a,
P. So
that's
you
technically
just
in
write,
the top.
So you just write positive 6 on it?
Positive 5p.
Yeah.
Now, we're ready to do the next division.
Oh, so
Sign.
it doesn't cancel?
No, well, it cancels for this division, but it's still left, we now have to divide it by this one. So now, sign,
Positive
number,
6.
and
Nothing.
cancels away, and there's our
I
answer.
got that.
Does that make sense now?
Oh, yeah.
All right.
That's
All right, how about number 10 then, on that note? Let's continue to work together, and then I'll have you work a few of these on your own in just a second. All right, so we've got this. All right, Joshua, sign,
Negative
number,
3
letter,
S.
S. Now, notice, Lana, this 1 canceled with one of these two, so we only have 1. But we don't actually cross it out, because we're going to need it for this next division. Sign,
positive. Negative.
number,
10.
and letter.
Nothing.
Nothing, it cancels. Now, we don't actually cross it out like we could have before, but mentally we kind of cross it out, and there would be our answer. And then number 12, we have, negative 16q squared r, negative 24q, all divided by a negative 8q. Lana, I'll start with you this time. Sign,
Positive.
number,
2.
letter.
Q, R.
Good. And then Joshua, sign,
Positive
number,
3
letter,
Q. I mean,
No.
Q's canceled.
cancel.
Okay.
And there's our answer. Starting to figure it out now? All right, go back and do the odds. 1 through 11 odd. 1 through 11, the odd. Lana's got them. Tell you what, Josh, I'll have you take the last one for me. For now, put your pencil down, let's check. So let's start with Lana. Sign, number, letter, what did you get?
4x negative 6.
Perfect, 4x negative 6. Joshua, the next one.
Negative 11y squared positive 5y.
Perfect. Next one, Lana, dividing the A now.
Positive 15a positive 16.
Perfect. The next one, Joshua.
Negative 8m squared negative 7.
Great job.
Oh,
The next to last
7m?
one. I thought you said negative 7m.
No.
I'm sorry, I misheard you. Sign, negative. Number 7 divided by 1 is 7, and the m squared divided by m to the first gives m to the first.
I just looked at it because 8m, like the m becomes an n squared, so I thought that both of them cancel.
Okay, let me say what I said to Lana a moment ago, because I guess you didn't catch it. This divides by the m. This m cancels with one of these three to leave you with 2. That's in that division. But now we're dividing it all over again, so the m doesn't disappear. It cancels that time, but it's available this time. Again, we could say this and this. So each one is divided separately. Does that make sense? Okay, so the m comes back. Like, it may cancel here, but don't actually cross it out because we're going to need it again to do the next division.
Yeah.
All right, I'll come back to you in just a moment with that idea on number 11. Lana, number 9.
Positive 3 divided by negative 2.
Good. And here, Joshua, again, we're going to start by just focusing right here. Sign, number, letter, we get?
Positive 6a.
All right, then, although yes, technically in that division, the a squared and a cubed cancel to leave us with just an a, everything's back on the table again for this sign, number, letter.
Negative 16.
And the a squares cancel again in that separate division. Does that make sense now? All right, for homework this evening, or for homework this weekend, I should say, do page 493, the homework 1 through 10. Page 493, the homework 1 through 10. Page 493, 1 through 10. We're going to practice more of this in our next lesson. And as I alluded to, remember that weird problem where there was a fraction left over? Yeah, I'm going to teach you how to handle those so they're not a big problem for you in our next lesson. Have a wonderful weekend, and you are dismissed.